going to focus on business functions. So this involves expressing business processes such as revenue, cost, and profit in terms of them, of the quantities produced and sold. So what are the basic definitions? So let X or Q, that means this can be any letter, be the number of units or items produced or sold. Then P be the price per item or demand. Okay, so we're saying that the number of units sold. So assuming you have 10 shoes you're selling, so your Q can be 10, or your X can be 10. So these are 10 shoes, right? So Q or X represents the number of units or items sold. Then P is the price per item. So the price is also known as demand. Okay, so we are going to use price, which is P, interchangeably with demand. Okay, then if P is equals to A plus BX, then this is called a demand function. So we are saying we can represent P, which is price, to be A plus BX. So of course we said X is the number of units or items produced or sold. So B is the coefficient of X, and of course A is of course a number. Okay, so A and B are both integers or numbers. Let's just call them numbers for now. So then R be the total revenue from selling X units. So we're also coming across R. So R is revenue. So this is revenue. So it's good to note that revenue is also known as sales. So assuming again you have 10 shoes and you're selling each shoe at 1,000 bob, then your revenue is going to be 1,000 times 10, which is 10,000. So again I say revenue is also the same as sales, right? Okay, then the total revenue is the product of the total number of items and the price per unit. So R is equals to quantity times demand, or quantity times price. So if P is equals to A plus BX, then R is equals to X times P, which is also equals to X times A plus BX, which is P. So this is actually very straightforward. So remember we are saying, so if R is equals to X times P, and remember we have said X is the number of items produced and sold. So in this case, let's say 10. Then P is the price. So you multiply P by the price, and remember we give the price a function, and this is the demand function. So if you want to get R, you simply do X, which is this X here, multiplied by P, which is this one. So instead of writing P, you write A plus BX. Then when you multiply this, you're going to get AX plus BX squared, right? So that is called the revenue function. So we're going on well. Then let's go now to C. So C is the total cost of producing X units. So remember, when there is revenue, there must be costs and there must be profits. So now what is C? C is the cost. So again, assuming you're having a shop and you're selling shoes again, so there's a price that you actually buy the shoes. So assuming you are a retailer, you go to the wholesaler and get the shoe at say 700 per shoe. Okay, so if you buy 10 shoes, so your X is equals to 10, then the cost of the shoes will be 700 times 10, which is 7,000. Okay, so if you sell now the shoes at a cost of 1,000, So you're selling now each shoe at 1,000, okay, and you still have the 10 shoes, remember. So now the revenue will be 1,000 times 10, which is 10,000. So now what will be the profit? Of course, now the profit will be the revenue minus the cost, which is equals to now 10,000, 10k minus 7k, which is 3k. So k, of course, I mean 1,000. So that's how you, so it's as simple as that. So now when we are looking at costs, so remember we have said cost is C. So when you're looking at cost, so C be the total cost of producing X units. The cost function involves, one, we have fixed cost, and we also have variable cost, and we also have special costs. So now what are fixed costs? So assuming again you have a shop, and this shop you sell shoes, so what is fixed cost in that case? Fixed cost could be, say, rent. Fixed cost. So an example is rent. Why is it a fixed cost? It means even if you don't sell one item, you must pay rent. So fixed cost does not depend on the number of items you sell. So whether you sell 0 or you sell 20 or you sell 100, you must pay the fixed cost. So that's called fixed cost. Now variable cost. So these are costs associated with the supply of raw materials and overheads for manufacturing each product, and hence dependent on the number of items. So the variable cost is, it's actually called variable. Why? Because anytime the quantity, which, and we said quantity can be Q or X, when quantity changes, the cost goes up. So assuming you went and bought 10 shoes to resell, okay, so we said each shoe is at 700 shillings, so the total cost will be 7,000. Now if you added now to be, say, 20 shoes, now if you have now 20 shoes that you've bought, each is still costing at 700, then now you're going to get what? The total cost be 14,000. So you can see by every purchase of the shoes, the cost is increasing. It's varying. That's why it's called variable cost. It varies with every change in the quantity of the goods. Then now we have the last one, which is special costs. So this is these are optional costs, and you can see they are related to storage, maintenance, or deterioration, and hence dependent on the number of items. Okay, so assuming you are storing items in a warehouse, so the more the number of items, the more you do what? The more the price or the amount to pay. Now the general function of the general form of cost function is C is equals to A plus BX plus CX squared. So this is the general cost function, where X, of course, again, this is a quantity demanded, A is the fixed cost, you have looked what fixed cost is, then B is the variable cost, and C is the special cost factor, where X is the quantity demanded, then C divided by X is the average cost per item. So again, now what does this statement mean here? Okay, C over X. So we are saying C over X is the average cost per item. So now again, assuming, remember we had 10 shoes, and each shoe 10 shoes, and each shoe was costing 700 shillings. So that means your total cost is 7,000 shillings. So now if you're told now get the average cost, so a simple average, as you all know, so the average cost of this shoe is going to be what? The total cost, which is 7,000, divided by the number of shoes, which is 10. So the average cost here will be 700. So that is the average cost per unit. So we have already done what profit is. So profit is revenue minus the cost. I think we had already demonstrated that before. then there's a point we call a break-even point. So what is a break-even point? A break-even point, this is a point where you're not making losses and you're also not making profits. Why? Because the revenue is equals to the cost, or you can also write it as revenue minus cost is equals to 0. It's the same thing. Okay, so at break even the revenue is equal to the cost, or revenue minus cost is equals to 0. That is the break even point. Now the next one is, so if, now we've already tackled this already, so now let's go now to an example. We are working out now some questions using the knowledge that we have just gained prior. So in a given production of product X, the total cost, which is C, is equals, so this is supposed to be is equals to, C is equals to 12Q plus 21,000, and the total revenue function is equals, R is equals to 15Q minus 2Q squared. So the first thing you asked is derive the total profit function. So when you get such a question, the first thing you do is, how do you get profit? Okay, remember you've already said, now to get profit, you do what? Revenue all sales minus what? Cost. So now we have been told to derive the total profit function. You already have the revenue function, which is 15Q minus 2Q squared. So this is the profit function, the revenue function. So minus the cost function. The cost function is 12Q, remember to put the brackets, plus 21,000. So now open the brackets now so that you have 15Q minus 2Q squared minus 12Q. So remember minus and this plus and this minus here, when you multiply them you actually get minus, so this will be now minus 21,000. So you get 15Q, now put the like terms together, minus 12Q minus 2Q squared minus 21,000. So eventually you get 3Q minus, so 3Q is 15Q minus 12Q is 3Q, minus 2Q squared minus 21,000. So that is your total profit function. The next one is the number of products to be produced at maximum profit. So underline the word profit. So because you've already gotten the profit function, it is the same profit function that we are going to use to get the maximum profit. So if you followed when we were doing in our earlier class, if you have not watched it, please go back and make sure you watch that class on turning points. So on turning points, what did we say? At maximum profit, or at maximum, remember maxima and minima, where we had a graph like this, and then we were saying this is your maximum point. So at maximum point the gradient is 0. So how do we get the gradient of a curve? By differentiating. That means we need to differentiate and then equate it to 0. That's what we are in essence doing. So what do? You get, so remember this is profit. This is a profit function. So to get the maximum profit, what do? You differentiate this function. Remember we are differentiating the profit function because we have specifically been told the profit, maximum profit. So dPr, remember the symbol for differentiating, by dq is equals to, remember when we differentiate this you get 3 then minus 4q. That's what you get by differentiating this profit function. You get 3 minus 4q. So what is the number to be produced at maximum profit? Once you've differentiated that, you equate it to 0. So equate this function to 0 so that you have 3 minus 4q is equals to 0. So take 3 to the other side, or take 4q to the other side, so that you'll have negative 4q is equals to negative 3. Then now, having gotten that, now you'll get negative 4q is equals to negative 3. So divide by 4 on this side, divide by negative 4 on this side. So when you cancel out, you're going to get q is equals to a 3/4. So that is your answer. So the number of products to be produced at maximum profit is actually this 3/4. Of course, in a real situation, you may not get exactly this. So this is a hypothetical situation, a hypothetical question. But now this is the right answer. So 3/4 is the quantity to be produced at maximum profit. Okay, so that's how to do that, to approach that question. What if you had been told what is the quantity, or what is the let me just remove this here so that I'm able to calculate the next thing. Now, another hypothetical situation. What if you're told what is the number of products to be produced at maximum revenue, or you're told at what quantity should you produce to maximize revenue? So maximum revenue. Remember, this is now a different question. So how would you get the maximum revenue, or the quantity to be produced to maximize revenue? So how do you do that? You take the revenue function, and the revenue function is r is equals to 15q minus 2q squared. So again, what do you do? Remember our curve. So if this is your revenue function, you're looking at this maximum point. Okay, this is what you're looking at, and at maximum point the gradient is 0. So that means you differentiate the function and equate it to 0. Okay, so you're going to have now, remember you're differentiating, so dr by dq will be 15 minus 4q. Okay, so the next thing now you do is equate that to 0, so that you have 15 minus 4q is equals to 0. So take 15 to the other side. Then now you'll have negative 4q is equals to negative 15. So divide by 4, negative 4 divided by negative 4. So that now q will be given by, of course, now 15 divided by 4, which is of course 3 point something. So that will be the quantity produced to maximize now revenue, not profit. Now remember, this is revenue. Right. So let's now go to the next one. So a firm has analyzed its operation condition for both process and cost. The following functions were the result. So you have P, which is 400 minus 4Q. Remember we said P is also called demand. So P is the price. So the price function is 400 minus 4Q. Then C, which is the cost, is equals to Q squared plus 10Q plus 30. And then Q is the quantity in units. Then you're told now determine the revenue function. So how do you determine the revenue function? So to get revenue, remember, we say getting revenue will be given by what? The quantity produced multiplied by the price. Okay, so just like we did earlier, we demonstrated that. So what is our Q? We already have Q as a quantity in units. You have already been told that the quantity is Q. So you'll have Q multiplied by P, and our price is given by 400 minus 4Q. So this now will be equal to 400Q minus 4Q squared. So that will become your revenue function. Okay, now what is the quantity to be produced to maximize revenue? So remember, this is our revenue function. So you're told what quantity or what Q should be produced to maximize the revenue. So what do you do? Again, the same drill. You're supposed to do what? To differentiate R because we are looking at revenue, maximizing revenue, and we already have the revenue function that we've just calculated. So the quantity to be produced to maximize revenue is you differentiate R, so dr by dq will be given by, now if you don't know how to differentiate, you can go to earlier class on differentiation. So that will be 400 minus 8q. So that will be your derivative. You differentiate the revenue function, this is what you get. So after getting that, the next thing, now it's the same drill, equate this to 0. So if you equate this to 0, you're going to get 400 minus 8q is equals to 0. So take this 8q to this other side. Now you're going to be having 400 is equals to 8q. So now to get q, that now q will be given by 400 divided by 8. So q is going to be what? So what is 400 divided by 8, which is 50. So your q there, the quantity to be produced to maximize revenue, is actually 50. Okay, now the price to sell the product. So now we already have the price, so the price function is right here. Okay, so P is equals to 400 minus 4Q, because you have been told what is the price to sell. So you just substitute Q with 50. So now you get price will be 400 minus 4 times 50, and this will be 200. So your price will be 200. Then you're told the next one is the profit level the firm will realize. So this again a little trick. So how do you get profit? That's when you need to start asking yourself, profit is revenue minus cost. So you have your revenue function and you have your cost function. Remember your revenue function here is 400q. Remember it's right here, 400q minus 4q squared. Now all this minus c, we already have our c, and our c is, remember to put brackets, q squared plus 10q plus 30. Then once you're done with that, now you can open the brackets. So again, if you open the brackets for this one, you're actually going to get 400 q minus 4q squared minus q squared. Now minus and plus, this minus and plus here, you're going to get minus. So minus 10q, then plus and minus again, you get minus, so minus 30. So of course you have to put the like terms together. So if you put the like terms together here, you'll have 400q minus 10q, then minus 4q squared minus q squared minus 30. Right, now having gotten that, now you can simply now work that out. 400q minus 10q, you get 390q, then minus 4q squared minus q squared, then minus 5q squared, then minus 30. So that will be the profit function. So now after getting that, you just now need to substitute your q with 50. Remember you got 50 here, so you just need to substitute your q with this 50 you actually got here. That now you're going to have 390 times 50 minus 550 squared minus 30. So the answer you get now will be the profit level the firm will realize. The answer that you get after simplifying this will be the answer right here. So that's how to tackle such a question. Now let's go to the last question here. So this last one here, so you're told that firm's demand function is given by P is equals to 100. Remember, this is either the price or the demand. So P is equals to 100 minus 2x, and the cost function is xcx. So C is the function of x. So don't worry when you see C in bracket x, it means C a function of x. So C, which is the cost, is given by 20x plus 3000, where x is the units produced and sold. So here we don't have Q, here we have x. So you're told find the revenue function. Again, this is pretty easy. Remember, again the same drill. We said how to get revenue. So revenue is given by the quantity sold, which is x, multiplied by the price. So we already have the quantity sold, which is x, and our price here is 100 minus 2x. So simplifying this, you actually get R is equals to 100x minus 2x squared. So that will be your revenue function. The next thing is you're told what is the marginal revenue. So what is marginal revenue? Marginal revenue is the revenue you get by selling one extra unit. So how do you get that? Again, you simply get that by just differentiating the revenue function. So you have to be careful about the revenue. If you're told marginal revenue, know you are working with the revenue function. So now differentiate the revenue function to get the marginal revenue. So dr by dx will be given by differentiate that, you get 100 minus 4x. So that will be your marginal revenue function. The next one is the marginal cost function. So to get what is the marginal cost function, first of all, this is the cost you incur by buying or producing one extra unit. Okay, so how do you get the marginal cost? By differentiating the cost function. So differentiate the cost function which we have here, which is C. So dc by dx will be, remember we are differentiating this function here, that will be 20. So when you differentiate the cost function, you actually just get 20. So 20 is your marginal cost function. Then the last one is the profit function. No, that's the fourth one, the profit function. So how do you get the profit function? You simply, to get profit, we have done this before, you simply do revenue minus cost. So what is our revenue? Our revenue in this case is 100, you should put in brackets, 100x minus 2x squared. Then minus cost, our cost function there should be 20x. So 20x plus 3000. So that is your profit. So now open the brackets. Let me just put something like this and write it here. So when you simplify that, you're going to get now 100x minus 2x squared minus 20x, and then minus and plus, you get a minus, so minus 3000. Be very careful with the signs here. So now this will be, remember this is the profit function, 100x minus 20x, you get 80x, then minus 2x squared minus 3000. So this becomes your profit function. Okay, the next one is the optimum level of output at which the profit is maximum. So again, underline the name profit. So you're looking at the level of output where profit is actually maximum. So what do? You simply differentiate the profit function, which is this one. You differentiate the profit function and equate it to 0, the same drill. So now dpr by dx, now you're differentiating, would be 80 minus 4x. Okay, so when you differentiate this function, you get this. So the next thing is equate now this function to 0. So 80 minus 4x is equals to 0. So 80 is equals to 4x. When we take 4x to the other side, so you get x. So x will be 80 over 4, which is 20. So 20 is the quantity to be produced to maximize profit. So see you next for the integration class.